Okay. Carbon has a mass of 12, hydrogen has a mass of 1, oxygen has a mass of 16, and sugar is C12H22O11. How can I have these light little elements weigh almost as much as lead, which is 207 point something? I think it's 0.9 or something like that. Yeah.
Because there's many of them. So like 12 times 12 for carbon and 14 times 1 for hydrogen.
Yeah. Okay. So we have 12 times 12 for carbon. We have 22 times 1 for H. So all together they add up. Okay. Excellent. And I now have a job for you. Okay. You get to get out of your seats.
Okay.
I have one request. Do not pour anything directly onto the pan. Measure things into beakers. There are beakers on the counter at the back there, okay? And my request is for you to bring me 6.02 times 10 to the 23 NaCl. What do we call a particle of an ionic compound? Is it a molecule? Formula units, yes. So I want you to bring me 6.02 times 10 to the 23 sodium chloride formula units. There's a bunch of salt here. Okay, I'll get some more spoons. All right, you can use beakers. You can use a scale. And if you get stuck and you're like, I don't know what to do, call me over. Okay?
Can you get salt? Just like and A.
Now, please feel free to take more than one beaker. So you can just take some of the salt with you. Okay, otherwise we'll run out of salt. All right. Yeah, you don't need all of that. Just take some in a beaker. Yeah. And once you have 6.02 times 10 to the 23 sodium chloride formula units, you're going to bring it to me and I'll check it for you. Okay? Whatever the number that is, gram of salt. What did you yeah. Well, I don't get asked. No, but not one of you. You need one more. Okay, bring it on up to me and I'll check yours. You don't have to bring everything, just the salt.
Do you want a calculator? Oh.
Uh-oh, 47.46. Did you take into account the mass of the beaker?
No.
Oh, sorry. Yeah, I think it's going to period. It's joking. Okay.
And once you got it, you can bring it up to me, bring your salt up to me, and I'll check it.
Wait, would be. Yeah. Oh, it tells me everything. So you get thrown. You see everything, bro.
It's 55, right? Yeah. 100.
Let's see the weight out there. You guys good? Too much. Yeah, I did. You guys good? So you think you're running out now? 6.02 times 10 to the 23.
47.
Yeah.
So it should that's how many I added, like.
Yeah.
You have one of them, okay?
I'm already.
Yeah?
So.
Let's add a little bit back in. Joe, this, your calculator is so useful. Why does it give you that?
Oh, let's use it. Okay. And now we say. Yes. I'll do something. We're back. You got it? Okay, let's see. Let's test you out here. Let's see. This puppy. Ooh, you're like 2 grams short. That was so cute. Now, why are you 2 grams short? That's a good question.
I think our scale might not be good.
Oh, that could be. Okay. We'll try again. Okay, you might need to check your zeroing.
Okay.
All right? All right, re-zero. Okay, you guys ready?
Yes.
All right, let's try this. I mean, you're like 0.2 grams off, but it's close enough.
Thank
Yeah?
you.
Okay?
Yeah.
Yeah, no, you're good. All right, so you can now put that away.
Thank you.
All right. You guys are next?
Yep.
Excellent. Nice. Good. Yep. You're within like 0.1 gram, so that's good. So there you go. You put that away. When you're done, you can just put it in one of the beakers, and if there aren't enough, you can just grab another big beaker and start a new beaker. You bring it to me when you're done. Yeah. Alrighty. You are 2 grams short.
Why is it?
I don't know why you're 2 grams short. Everyone is not 2 grams short. 2 people have had it good so far, so go try again. Did you zero it with the pan on?
Yeah.
Okay, let's go take a look. Oh.
Don't know your brother might have some stuff. Oh, no. Don't let Joe know.
Hydrated salt, yeah.
It's so cool.
Oh my god, I can take you out. I don't know what I was there.
Yeah. That will keep going up, bro. Yes.
Okay, and now we're gonna. Okay? If you're finished and you are waiting and you're just bored, you could work on
3 grains.
5.1D.
There's actually not. Safely.
So if you're bored and you're waiting, 5.1D. You ready? Oh. You're not ready? Oh, that was the extra. Yeah, bring it on up. Perfect. Yeah, no, it's all good. Yeah, no, that's okay. It's all good. Okay. Oh, you have only part of it. Did you only go with sodium as opposed to sodium chloride?
I think that's why.
Because I've got 23 grams each here,
Yeah.
which would be 1 mole of sodium, but I want 1 mole of sodium chloride. Try again. Okay.
Thought we were not. Jonah's overpowered, so.
You're still over 1 gram, but I'm going to say close enough.
1 gram.
I'm going to say close enough. Right? You should have 58.5, right?
Right, yeah.
Yeah? I don't know why you're less, but you know what? We'll just say close enough.
Okay.
All right?
Put that back in there.
Yeah.
35.
Can I check your scale for zeroing? Just to make sure. Okay, what is it? You're good. Hi, you guys ready? All right. Let's try this here.
How much does
Beautiful. Nice. Okay.
how much do they cost?
These ones, like hundreds of dollars. Yeah. So anyway, that is for you. Congratulations, you are done. Here you go.
Where do I put these?
I will take that. Thank you so much. Back in one of these. Okay.
Bro, what is
I'm gonna already
Should I wash it?
Yes, please.
Emily.
That's true. They put them in uniform in Maya and
Yeah.
Emily. Yeah, and they're chains. We were visiting. That's the difference. Also, the next piece. Yeah, we're fine. Middle. Two.
Right. They play 6 back. Right. Where's D? This D? Why did you have a periodic table? I didn't. You stole my periodic table. But you know what you can do?
Oh,
I'll zero Doria. Because we're just 2 nights and you did.
So, just in case you're wondering what your homework is on the weekend, 5.D, 5.1 D, E, and F, and 5.2 A, B, C, D. I think you've done A and B already, though, right?
Yeah. And I.
Hang on a second. What did I give? We've done 5.2 A and B, so it would be 5.2 C. Yeah, 5.2 C and D. There we go. That's better.
Hydroxide.
Oh, I know what I did wrong. I'm sorry. No, okay. 5.1
Yeah.
C C D E F C D E F. Yes.
Yeah, we did 5.2.
2 F and then
We
5.2.
did 5.2D as well.
You did 5.2D?
Yeah.
Cool.
Yeah, we did it when we did the college lifting. Wait.
Good. Yes.
Oh.
So you guys can just clean up now.
Total average?
Oh. Kill
How much total average? And these.
5.1 C D E F. Yes.
This?
You got it there, Jonah Edward? Yeah? Bring it on up. Because I want to go over 5.1C with you guys before you go. Okay?
Here we go. We finally.
Excellent. Excellent.
I think.
Okay. Yay, you're good. All right.
It would be. Six.
Yeah.
You have a whole bunch of this.
Yes. Now, the question is where did I put it?
This is what do you
Yeah, crap.
obvious one. Not that one.
How come term two and hydroxide is term one? Although it's not my house.
Yeah, okay.
Because it's not on the from. I have to like balance it also.
Tin.
Oh, it's not.
What's tin? What's tin? Tin is acid. Carbonate.
Actually, USB.
So it should be 2 and this is 3. And that's a 4, right? That's a 4. So then there's 2 and 4. So that would be 6. Right? Is that?
Oh.
This has how many? 4. 4. And then this has 2.
Is it 2, 3?
How?
I'm drawing.
Because there's 4. Because tin has a term is 4 or carbonate or 2.
I'm drawing. That's it.
Oh. Oh, 1. Oh wait, 4. 5 to 5. You're 5 other. 5.
Okay, ladies and gentlemen, I want to spend a little bit of time with you on page 14.
6, 7, 8.
Okay.
8. 6. Oh, there's 3.
Because that's going to set you up to do
Time and all the time.
5.1E and F.
I don't even know.
Okay?
8.
Oh, actually, we got E and F already. D, E, F. Yeah, okay.
8.
How's there 8?
Just 2 minutes.
Okay, so here we have on page 14 carbon dioxide. How many atoms of oxygen are in carbon dioxide? 2. 1, 2. Yay. Okay. And now if we wanted to write this as a conversion factor, we could say I have 2 atoms of O per 1 CH4 molecule. Or I could write it upside down. I could write it as 1 CH4 molecule for every 2 Oh, why am I writing CH4? Because my brain is not braining. CO2, there we go, CO2 molecule, CO2 molecule per every 2 atoms of O. So that is what we call a particle ratio. It tells us the ratio of one particle to another particle. So within that CO2 molecule, which is a particle, you have 2 oxygen atoms, 2 particles, okay? And the only way to find the particle formula is you find it by looking at the formula. Okay? Now, how many atoms of oxygen are in 3 molecules of CO2? 1, 2, 3, 4, 5, 6. But probably we don't want to spend our time counting atoms. Yes, because these are small numbers, but most of our numbers will be big and ugly. So we want to be able to calculate this. So we say, how many O atoms do we have in 3 molecules of CO2? And we do this using the particle ratio as our conversion factor. Okay, so the particle ratio is the conversion factor. So where do molecules of CO2 have to go? They go on the bottom, so we want molecules of CO2, and we want to find oxygen atoms, so O atoms. That means molecules of CO2 cancel out, and we have 2 O atoms for every 1 molecule, and that gives us, lo and behold, the same number we counted up, 6 O atoms. All right. How many CO2 molecules could you make given 8 oxygen atoms? Here's our 8 oxygen atoms. 1, 2, 3, 4, 5, 6, 7, 8. How many CO2s could we make? 4. C, 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 C. 4 CO2s. But again, we're not going to have lovely numbers like 4 and 3 and 6, okay? So we want to be able to show that. So we say, how many CO2 atoms, how many CO2 molecules, sorry, not atoms, can we get given 8 oxygen atoms? This time, what has to go on the bottom? Oxygen atoms. 2 of them. And on the top, we have our 1 CO2 molecule. And lo and behold, we still get 4. O atoms. Okay. And we're going to do the next one just because it gives you a little more variety. Okay. Given a molecule of methane. Ooh, we have that prefix meth. What does meth mean? This is methane. Meth is 1 carbon. Okay, so we have methane and it's got 4 hydrogens attached to it. And that's because carbon has only 4 valence electrons, so it needs 4 hydrogens to covalently bond to give it a full valence shell. Is that looking familiar? Okay, so let's write ourselves a conversion factor between molecules of CH4 and atoms of H. Do you guys think you can do these ones on your own? Yeah? I got 2 people nodding. I got a thumbs up. I got nods over here. Okay, do it, and then I'll put them up and you can check them. Oh no. I'm recording and I'm very confused and I just said I'm so effing confused. So a little colorful language on that. I just whispered it, right? I'm like, so confused. There was another word in there. Oh dear. By the way, it doesn't matter if you write molecules of CH4 or CH4 molecules. That order doesn't matter, okay? So you can check your answers here. And then actually, I'm going to give you another one to do. Just generic atoms. How many generic atoms are there in one CH4 molecule? There's 5. Okay, so we can do like carbon atoms, or we can do hydrogen atoms, or we can do how many of all the atoms? Okay, we've got lots of different options. And so when I write and that like or and that little swishy arrow, that just means you could flip it upside down. So if you wrote it upside down, that's okay. All right? Doesn't matter which way you wrote it. You can always flip them upside down. Would you be able to solve 3A? Yeah, give it a try. Okay, so try number 3. Why have you done A and B? Why do I keep writing A and B? Cindy, why did I have so many last year? I think that's right. Yeah, okay. That's all right. We can always push it till Friday if we need to. Okay. Time. Yeah. Is that what? Yours? After that, yes. Except for I think we've done this and this already. So I guess it's just C and D. Pardon me?
D?
Huh? Have you done D?
Oh, yeah, we did.
Oh. Well, maybe I need to Okay. Oh, you could, yeah, okay. What's that?
B.
B? You haven't done B. Oh, okay.
haven't done
So
B.
you could do
No, just B.
B. So you could do B and C. Oh,
Wait, we did A and A.
you've done B and A. Oh my God.
But we did 5.2A? Yeah. Why did I not do 5.2?
Okay. Let's just make sure, because you know what? I had a problem with my other class because I told them the wrong thing last block. So now I'm really confused, which is why I was so confused, right? Okay. But I think you guys could actually do 5.1 D, E, because I think we've already done some of those, right? F, G. Okay. And then 5.1 B, C, D. Ooh, do you want to try 5.2E? 5.2 A, B, C, D, E. And if you've done some of them in the meantime, because some of you are telling me you've done 5.2D, how many people have done 5.2D?
5.3.
5.2D, as in dog. Okay, so you've already done that. So try E. Okay? And because that's a lot of pages, although some of them aren't a lot of work, don't necessarily do every question. Do like every second question or every third question. Okay? And we'll have some time next week if you need to, do some more practice on it. Okay? And the answer for 3A, so we have how many carbon atoms? So we need to have carbon atoms on the top and CH4 molecules on the bottom, and that's a 4. No, it's not a 4-to-1 ratio. It's a 1-to-1 ratio. Yep, there's 1 carbon in CH4. And that gives us 128 carbon atoms. How many hydrogen atoms are contained in 128 CH4 molecules? Well, there's 4 hydrogen atoms in every 1 CH4 molecule. I think that gives us 512, doesn't it? Yeah. I did them all in powers of 2 so that it would be easy to remember them. How many molecules of CH4? So how many CH4 molecules could we make from 128 hydrogen atoms? All right. And we need to cancel hydrogen atoms, and we need to find CH4 molecules, and it's a 1 to 4, and that is equal to 32. CH4 molecules. Is this becoming pretty straightforward? Okay. Do we need to do the last one? No. Okay. So probably most of these will be very straightforward. And like I said, don't feel any obligation to do more of them than you need to. I do not want this course to be about busy work. Okay? I want it to be about understanding. So if you feel you need to do them all to understand it, that's fine. But feel free to do just, a smattering. Yes?